Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is 3.7, Graphs of Polynomial Functions, Day 1. What you see in front of you right now is 4 different polynomial function graphs. The first one is y equals x squared, then we have y equals x to the 4th, y equals x cubed, and y equals x to the 5th. What we're going to do here is we are going to talk about the end behavior. The end behavior is where our graph ends. So for the first graph, those 2 points are our end behavior. Okay? What I want to know is, does our end behavior go up or down? Okay? So at the end, this is going up. All right? Another piece of information you're going to want to know, all right, is on anything from 0 this direction, we're going to call x, we're going to call that x approaching positive infinity. What that means is that my graph is moving to the right. Anything from 0 this direction, we're going to call x approaching negative infinity. And that just means that my graph is going to the left. Anything from 0 up, I'm going to call y is approaching positive infinity, just means our graph is going up. Anything going down over here, we're going to call y approaching, y approaching negative infinity, just means that my graph will go down. All right? So don't get freaked out by the infinity notation. It just means right, left, up, and down. All right? Y's are always up and down. X's are always right and left. Now, the information that is really, really important to me in this situation to figure out our end behavior is going to be the leading coefficient of our polynomial and the degree of our polynomial. Okay? So in the first problem, my leading coefficient, the number that comes before my x, is going to be positive. Okay? If my leading coefficient is positive, you can actually see the graph here. Both sides of my graph are going to end up opening up, right? So the left-hand side goes up, the right-hand side goes up, right? So what we're going to say is we need to write something, our end behavior, in infinity notation. I'm going to use 2 different colors so that you can tell the left side infinity notation and the right side of the graph's infinity notation apart. I'm going to use blue for the left because there's an L in blue, and an R for the right because there's an R in right. So as x approaches negative infinity, it just means as my graph moves to the left, what did my y do? It approached positive infinity, right? What about as my x moved to the right? As my x approached positive infinity, my y went up, so it approached positive infinity. So in the blue line, as my x approaches negative infinity, or as my graph moves to the left, does my graph go up or down? Well, the y tells us there that it's going to go up. And as x approaches positive infinity, the red line, as my graph moves to the right, my y is also going to open up. There is another graph that we want to take a look at. What if I had a graph that looked like that green graph down below there? What that means is my graph has reflected over the x-axis, so my leading coefficient is actually going to be negative. What happens here is my x's are going to stay the same. It just talks about my x moving to the left and my x moving to the right. Okay? But my y's are going to be opposite. Just like that graph is opposite the first graph we looked at, my y's are going to be opposite. So they are going to approach negative infinity. So let's take a look at that on the graph. So as x, the blue line, approaches negative infinity or moves to the left, my y is moving down. So that is why my y approaches negative infinity. And as my x moves to the right, my graph goes down, so the red line there, as x approaches positive infinity, y approaches negative infinity because it opens down. All right? Let's go ahead and look at the second graph here. It looks very, very similar, does it not? On the left-hand side, I'm going up. On the right-hand side, I'm going up. My leading coefficient, not the equal sign, I'm sorry. The number in front of x to the fourth is positive, so my leading coefficient is positive. So now what I need to figure out is, as my graph moves to the left, so as x approaches negative infinity, what does my y do? So as x approaches negative infinity, my y is going up, so y approaches positive infinity. Let's take a look at what happens as my x moves to the right. So as x approaches infinity, moving to the right, what's my y doing? It is also approaching positive infinity. You might be able to start seeing a pattern there. We'll talk about the pattern here in a little bit. Okay? Let's go ahead and look at the opposite graph just like we did before. Okay? So, my leading coefficient of this green graph is going to be negative because it's the opposite. As my graph moves to the left, so as x approaches negative infinity, y is going down, so y is also going to approach negative infinity. How about as my graph moves to the right? Well, we call that x approaching positive infinity. Y is approaching, it's going down as I move to the right, so it's approaching negative infinity. All right? Let's continue. Okay? So now I have an odd degree. I have the third degree. But my leading coefficient is still positive. So my leading coefficient is still positive. But with an odd degree, what you're going to notice is that our end behaviors are opposite one another, right? The ends of our graphs are opposite one another. On the left-hand side of this graph, it goes down. On the right-hand side of this graph, it goes up. Okay? So let's write that information in infinity notation. So as x approaches negative infinity, or as x moves to the left, what did my y do? Well, it went down, so y approaches negative infinity. As x approaches positive infinity, or moves to the right, just like this line, what did my y do? It went up, so y approaches positive infinity. Okay? There is another graph we can take a look at. That would be a graph that would look similar to this. Okay? That is the opposite. So in this case, my leading coefficient of my second graph there would be negative. Okay? So in that second graph, as x moves to the left, my y went up. So as x approaches negative infinity or moves to the left, my y went up, so it approaches positive infinity. As my graph moves to the right, or this red part of the graph that I just drew, so x approaches positive infinity, moving to the right, y has gone down, so y approaches negative infinity. Okay? Let's see if there's a pattern with odd degrees. So looking at this problem, my leading coefficient for my black graph is positive. Okay? So what happened in this case? Well, on the left-hand side, it went down. On the right-hand side, it went up. Just like the last time, right? So as my graph moves to the left, my y went down. How do I say my graph just moved to the left in infinity notation? It would be x approaches negative infinity. How do I say that my graph went down in infinity notation? Well, it would be y approaches negative infinity. How about moving to the right? The red portion of the graph. As x approaches positive infinity, moving to the right, what did my y do? It went up, so that approaches positive infinity as well, or that means it went up. Okay? Now, we need to look at the reverse of that. Again, it would be something along those lines. Okay? So what if my leading coefficient is negative? Well, as x moves to the left, my y has gone up. How do I say x is moving to the left in infinity notation? X approaches negative infinity. How do I say y went up? Y approaches positive infinity. Now I need to look at this red portion. So x is moving to the right. So x approaches positive infinity. Y approaches negative infinity. Okay? Based off of those four graphs, what you'll notice is when my degree is even. So this problem and this problem, there is a pattern there, right? Well, what is the pattern? Well, if I have an even degree, this is the most important thing that you need to figure out right here. We did all that work with those visual aids up there to figure out our rules list. This is our rules list. If I have an even degree and the leading coefficient is positive, then x is going to approach negative infinity. Just means I'm moving to the left. My y will approach positive infinity. And as x approaches positive infinity, my y will approach positive infinity. Okay? All right? What if my leading coefficient were negative? It just means the opposite, right? Well, my x's in infinity notation never change. They're always x approaches negative infinity and x approaches infinity. But my y's will flip in this case. Okay? So when I have an even degree and my leading coefficient is positive, my y's will both be positive. If I have an even degree and a leading coefficient that's negative, then my y's will both be negative. All right? The other thing that we looked at were odd degree problems. There was a definite pattern there with the odd degree problems as well. What was the pattern for when my leading coefficient was positive? Well, as x approached negative infinity, let's look up here at my graphs. As x approached negative infinity, my y approached negative infinity. And as x approached positive infinity, my y's approached positive infinity. Okay? That's with an odd degree and a positive leading coefficient. What if I had a leading coefficient that was negative? Well, your y's would just switch then. My x's always stay exactly the same. The sooner you figure that out, the better off you'll be. But my y's, because my leading coefficient switched, my y's will also switch. So that rules list will get you through every single one of these problems, because what we're going to do now, instead of having a graph and just looking at the graph to figure out what happened, we are just going to have the polynomial. We're just going to have the function. Using the function, we will be able to say, we'll be able to tell the end behavior based off of our rules. Okay? So for problem number 1, let's just work all the way through problem number 1. My leading coefficient, the sign of my leading coefficient is negative. My degree is my largest degree. In this case, it is 3. Is the highest exponent odd or even? So is my degree odd or even? It is odd. So based off of our rules list, we can say what the end behavior would be. Remember that the x's never change. It's x approaches negative infinity and x approaches positive infinity. However, let's look at our rules list. An odd degree with a negative leading coefficient, it tells us that as x approaches negative infinity, y will approach positive infinity. So let's fill that in. As x approaches negative infinity, y approaches positive infinity. The thing to remember about odd degrees is your y's will always be opposite of one another. So y would approach negative infinity. We'll talk about the maximum number of turning points and maximum number of roots here in 1 second. Let's move on to problem number 2. My leading coefficient, there's no number out front, which means that my leading coefficient will be positive. My degree is 5, which means that it is odd. Okay? Remember that our x's are always the same. Okay? So let's go back to our rules list and find our odd degree, positive leading coefficient. As x approaches negative infinity, y approaches negative infinity. Y approaches negative infinity. Remember, with odd degrees, your y's will just always be opposite, and we are done with our end behavior. Okay? On to problem 3. So in problem 3, my leading coefficient's negative. My degree is 2. So that means I have an even degree. Okay? Remember, my x's will always be the same. Nothing's changing there. Okay? But we can go back and take a look at an even degree with a negative leading coefficient. What I want you to notice about the even degree stuff is whatever my leading coefficient is, that's where my y's are going to go. So since it's a negative leading coefficient, my y's will go negative. Okay? So since I have a negative leading coefficient and an even degree, my y's are going to approach negative infinity. Just means that both sides of my graph will open down. Okay? Problem 4, there's nothing in front of my x to the 4th, and my degree is 4. So I have a positive leading coefficient. My degree is 4, which is even. My x's will never change. So as x approaches negative infinity, remember, with even degrees, your y's will follow the leading coefficient sign. So my y is going to approach positive infinity and positive infinity. Okay? On to problem 5. My leading coefficient is 2, which means I have a positive leading coefficient. My degree is 9, which means I have an odd degree. We've already worked with a positive odd problem, right? My x's are always the same. So if I have a positive odd problem, my y is going to approach negative infinity, and my y will approach positive infinity, and we are done with that problem. On to 6. I don't have a leading coefficient, so that means it's positive. My degree is 8, which means I have an even degree. We've already worked with a positive even degree. As x approaches negative infinity, x approaches positive infinity, y will approach, if it's an even degree, I follow the sign for both. Okay? All right? All right. Now, maximum number of turning points. This is actually pretty easy. The maximum number of turning points is going to be 1 less than the degree. It's 1 less than the degree. So my degree in the first problem is 3. That means my maximum number of turning points will be 2. My degree in the second problem is 5, so it'll be 4. I had 2 for my degree in the next problem, so I'll have 1 turning point. I have 4, so I'm going to have 3 turning points. I had 9, so I'm going to have 8 turning points. And I had 8, so I'll have 7 turning points. Okay? Now the maximum number of roots, that is also pretty easy. It's just going to be my degree. If you remember from not too long ago, we talked about roots and x-intercepts as being our number of solutions, right? Well, how did we figure out how many solutions we were supposed to have? It is my degree of the polynomial. So in this case, my degree was 3. So I'll have 3 maximum number of roots. 5 for the second problem, 2 for the third problem, 4, 9, and 8. All of those numbers just came from my degree column because they are the same thing. All right. Now, you may be asking yourself, what is a turning point? Well, if you're looking at a graph, and a graph goes like this, there's 1 turning point, there's 2 turning points. So I'd have 1, 2 turning points, which means I had a third degree graph. If you see another graph that does this, I had 1 turning point that was right there at the middle. Okay? That's what a turning point is. It's just where your graph ends up turning. Makes a lot of sense to be called a turning point, right? All right. Let's move on. We're going to do exactly the same thing that we just did in the table. It's just not going to be laid out for us. So I need to identify the sign of the leading coefficient. So for problem 7, my leading coefficient is this -5, so it means I have a negative leading coefficient. Then I need to figure out my degree. Well, my degree in this case was 3, which means I have an odd degree. Now we need to tell the end behavior. Well, if you don't know it off the top of your head yet, you can always look back at your rules list. Okay, I have a leading coefficient that is negative, and I have an odd degree, so as x approaches negative infinity, x approaches positive infinity, that will never change. Here's another tip. If you have an odd degree, the y that's on the bottom will take the sign of the leading coefficient. Okay, the y that's on the bottom will take the sign of the leading coefficient. And with odd degrees, it's a little bit of an oddball. They don't want to follow each other, so the opposite y will always be opposite. Okay, O, opposite. All right. Problem 8. Again, I need to know my leading coefficient's sign. In this case, it's 3, so it'll be a positive sign. My degree was 7, which means it's an odd degree, right? So as x approaches negative infinity and x approaches infinity, again, that never changes. All right. Remember, with odd degrees, that the y on the bottom will take the sign of my leading coefficient, so it'll approach positive infinity. My other y is going to be opposite, odd, O, opposite. Okay? On to problem number 9. My leading coefficient is positive 3, so it'll be positive. My degree is 6, so it'll be even. As x approaches positive infinity, x approaches negative infinity, right? We're good there. It's the same thing every single time. Now, what you need to remember about even degrees is both of your y's will take the sign of the leading coefficient. That's a little shortcut. If I have an even degree, both of my y's will take the sign of the leading coefficient. On to problem 10. My leading coefficient is this negative 3, which means my leading coefficient is negative. My degree is 2, which means it's even. As x approaches negative infinity and x approaches infinity, my y's, because it's even, will always follow the sign of the leading coefficient when I have an even degree. So negative infinity and negative infinity. Okay? On to problem 11. Decide whether the graph has an even or odd degree. That's easy. We can tell if it has an even or odd degree depending on what our end behaviors are doing. If they are going opposite of each other, O, opposite, odd, O, opposite, odd, okay? And does it have a positive or negative leading coefficient? Well, remember that the right-hand side, or the bottom y, when I have an odd degree, will take the sign of the leading coefficient. Well, here's my right-hand side. It's going up, so the sign for that would be positive, right? Which means that it has taken the sign of the leading coefficient, so the leading coefficient sign would be positive. Okay? Number 12, my end behaviors are going the same direction, so that means they're going to be even. They want to be the same. Now, with an even degree, my end behaviors will take the sign of the leading coefficient. In this case, they're both going down, so my leading coefficient is going to be negative. That is the end of our lesson. A couple things to remember real quick. If you can memorize your rules list, you are golden. There is nothing to worry about. You're going to have this down in no time flat. If you do not memorize it, there are a couple tricks that you can use. If I have an odd degree, then my bottom y will take the sign of the leading coefficient. If I have an even degree, then both of my y's will follow the sign of the leading coefficient. Okay? Remember, if you are struggling with this stuff, if you did not catch any of this, please make sure you come in before school. Let me help you out. I will go through some of this in class tomorrow, but if you can get some one-on-one time, it's only going to help you. All right? Well, thank you very much for watching the video, and have a great day.